Guys, welcome back to Math Zone African Motives, still on mathematics grade 10 level. In this platform, we shall be focusing on the question paper, which was written in November 2018. That's the paper 2. We worked with paper 1. So now we are going to focus on paper 2 as we are preparing ourselves for the exams, which are ahead of time. That is the most important part that we have for us to revise. So don't forget to share our videos and our platforms to your friends and colleagues so that they also can benefit from this information. All right, so as you know, guys, you must read the instructions. That is the information that you're given, especially the number 5-1 is the one that I most want to focus on. Your answer should be to 2 decimal places unless stated otherwise that you might be given another option. But if not, then leave your answer to 2 decimal places. If any answer is not to 2 decimal places, guys, okay? So we are not going to waste much time. Let us quickly rush through the questions. We've got question number 1, where we are given the line graph below shows test marks out of 10 obtained by a grade 10 class. So it was actually a test which was there out of 10. So we are given the information in form of a line graph. So remember, on your line graph, what is important is the frequency axis here. Each and every part corresponds with the frequency. So we've got the marks as 0. There's no 1. There are 3 of them. 2. There are 4. 3. There are 5. 4. There. So that is how you take this information. All right. So from this information, we are given the first part of the question on 1.1 to complete the frequency column in the table provided in the answer book, and that is 2 marks to complete. So let's check the frequency column table that we have. That was the frequency column. We were given the marks obtained, and corresponding is the frequency here. So what you need is to take the marks, then the corresponding frequency from the graph that we have. So let's start with S0 here. How many obtained S0? That is the concept. So you can check here S0, there is no one that is S0. So which means 0 corresponds with S0 here. You move on to 1, you do the same thing. 1 corresponds here straight with 1, it goes straight to 3. So 1 corresponds with a frequency of 3. So this is frequency. We're taking the equivalent frequency, which is 3. We move on to 2. 2 here corresponds with 4. It's 2 straight to this point, then straight to this point. It corresponds with 4. So that's 2 versus 4. Then we move on to 3. That is 3 from the graph here. It corresponds 3 straight to the graph, then straight to the frequency axis. It corresponds with 5. So that is 3 versus 5. Then we've got 4. According to the graph, 4 here corresponds 4 straight to the graph. That is a 3. All right, so that's 4 versus 3. 5. It's the same thing, guys. We do the same thing on 5. So 5 straight here corresponds with 6. So that is the frequency on 5, which is a 6. Then we have got a 6 here. 6 corresponds with a 0. There is no one here straight to the graph. That's a 0 there. So it's 6 versus a 0. All right. Then we have got 7. 7. All right, let's just try to retake this graph. So let's take straight 7 to the graph. It is this point, then straight to the graph here. It corresponds with a 7. So it's 7 versus 7. Then we move on to 8. 8 here straight to the graph, then straight here. It corresponds with a 9. So that is how you simply take the information from the frequency that you're given. So we say this one, it corresponds with a 9. Then we've got 9. It corresponds with 9 here, straight to this point, then straight to the graph. That is a 5. So that's 9 versus a 5. All right, then we move on to the other one. That is 10 versus a 0. There's nothing here straight. That's a 0. So it's 10 versus a 0. All right, so that was the information you simply take from the graph straight as it is. All right, so let's check the other part of the question now that we're given on 1.2. We are now given how many learners wrote the test. All right, so this we can actually take from the information that we have here. This is the frequency. So we simply have to add everything that is the total frequency. Those are the number of learners which were part of the test, or the test. So let us add our frequency. We can even use our calculator. That's 3 plus, for this is 0, so there's nothing that we have. So we add 4 plus 5 plus, we move on to 3, right, plus 6 plus a 7. All right, that's a 7 here, plus a 9 plus a 5. All right, so we've added everything. It adds up to 42. So that is the frequency that we are obtaining in this case, which is a 42. The total frequency, those are the number of learners who wrote the test. Then if we can cross-check on 1.3, we've got 1.31. Calculate the range of the data that you're given. So from the information that we have, or from the data that you are given, what is the range? Remembering that range is equivalent to the maximum minus the minimum value, which is being scored. So you're talking about the max. So range is equivalent to the maximum minus the minimum value. Okay, so this is the maximum score and the minimum score that we're being scored. All right, here, according to the scores that we have, at 0 there, we do not have anyone who scored a 0. So which means the minimum score which was scored is a 1, because there are 3 students or 3 learners who scored a 1. Okay, so this is the frequency. So the minimum value that we have, that's a 1. Then to the maximum, it was supposed to be 10, but 10 here, there is no one who scored a 10. So that means the maximum value is going to be 9, because there are 5 learners who scored 9. So that is your maximum value. All right, so from this information, that means the range is going to be the maximum, which is 9, minus the minimum here, which is a 1. All right, so if we subtract this, guys, this is 8. There's no need of a calculator here. All right, so that was the range of the given data, or the given information on 1.32, the mean for the test. All right, so remembering that mean, we can take this from the table that we have. We are supposed to have our mean as, right, let's get back to that paper on that page. All right, so this is the mean. We can even calculate it here. Let's just hope it's going to be fine. All right, so remember that mean is actually given as x bar. You can write this as x bar, which is actually the sum of terms over the number of terms. All right, so we've got sum of terms over the number of terms. That is, how many terms do we have there? Okay, so for the sum of terms, if you are given a table like this, take note, you are going to multiply in this case, because we've got a score of 1. It was scored by 3 learners. So it was supposed to be 1 plus 1 plus 1, 3 learners who scored 1. So instead of writing 1 plus 1 plus 1, we can simply multiply 1 and 3. The same thing 2 here, it was scored by 4 learners. So it was supposed to be 2 plus 2 plus 2 plus 2, 4 times. So you simply multiply 2 and 4. So that is what you're going to do. Then we divide by the total frequency. All right, so that means, okay, let's just try to increase a little bit. So maybe it's gonna help us here. All right, let me do this a little bit. Sorry for that, guys. All right, so let's check now according to the information. The first one, that's a 0 there, and we've got none, because that's 0 versus a 0. So we're going to move on to 1. So this will be 1 versus 3. Okay, so we're going to multiply 1 and 3. So that is our mean, which is x bar is equal to 1 times 3 plus, we move on to the other one, which is 2 here. So that's 2 versus 4. So it's going to be 2 times 4 here. All right, so you're going to multiply 2 and 4. So this is going to be plus 2 times 4. Plus, we move on to the other one, which is 3. So if we can check here, is 3 versus a 5. So you're going to multiply 3 and 5. So this is 3 times 5. Plus, you move on and so on and so on up to the last term, guys. That's what you're going to do. So that's 4 here versus 3. So it's going to be 4 times 3. All right, so we've got 4 times 3. Then we move on to 5. 5 corresponds with 6. So as we can see here, it's 5 versus a 6. So that's 5 times 6. So we're going to have 5 multiplied to 6. Plus, we move on to the other one, which is a 6. So 6 here corresponds with a 0. That's 6 and a 0. So there's no need. You can multiply. Yes, you can multiply 6 times 0, but guys, 6 times 0, that's a 0. So let's move on to 7. So we've got 7 versus a 7 here. So it is going to be 7 times 7. All right, plus we move on to 8. So 8 here corresponds with 9. So it's going to be 8 times 9. So that's plus 8 times 9. All right, let's do this. This is a times. So that's 8 times 9. Plus we move on to 9 here. 9 corresponds with 5. So it's going to be 9 times 5. So that's 9 times 5. 10 corresponds with a 0 here. That's 10 versus a 0. So we can even leave it like that. All right. So that is what you're going to have on the sum of terms. Then everything here. All right. This division line is ugly, guys. All right. So let's do this. Let's try again. So we are going to have our division line in this case. All right. So that is the sum of terms over the number of terms. So the number of terms is actually the total learners, that is the total frequency. So there is no need for you to redo, because remember we calculated the total frequency here, which is the total number of learners, which is 42. So you're just going to divide this whatever that you have by 42. All right, so that's it. That's the mean. So on the top there, all you need is your calculator to simplify everything. Okay, so that's 1 times 3 plus 2 times 4. So guys, you have to use your calculator. Plus 3 times 5. Okay, plus 4 times 3. That's a bracket. 4 times 3 here. All right, I left a 3. That's 4 times 3. Then we move on to 5. Let's see, on 5, that's 5 times 6. So it's plus 5 times 6 in a bracket, 5 by 6, plus 7 times 7. Okay, that's 7 times 7 here. Plus, we move on to 8. That's 8 and 9. Then to 9, which is plus 9 times 5. So that's the total of 234. All right, so we are going to have 234 over 42. All right, so let's see what do we have here if we are to divide 234 divided by 42. That is 9 over 7, or as a decimal, that's 5,571 and so forth. But remember, to 2 decimal places is going to be 5,57. This one cannot affect the 7, so it will be 5,57. So this can be 5,57. So that was actually the mean mark or the average. So this can be the mean for the test, or it can be the average. So mean is actually the average, so it can be the average. All right, so what's the information, guys? As you can see, that's how you simply have your mean from this information that we had. All right, so it was actually 3 marks from this information. That was actually 3 marks. So let's check the other part of the question. We are now given on 1.4, determine the median for the data that you're given, and that is actually 3 marks. So for you to have the median value, you are going to work with Q2. That is, remember, we've got Q1, Q2, Q3 from our quartiles. All right, so let's see from this table that we have. So I'm just going to utilize this space aside, since we do not have any space that we have. So I'm just going to use this part here. So remember that we are supposed to calculate the median value. This is a 1.4. So we need the median. So median can be written as a Q2. All right, whereby Q2 is equivalent to n plus 1 over 2, whereby n is representing the total frequency or the total sum of the distribution. So that gives us the position actually for Q2, where we are going to obtain the value. All right, so if we are to add here, n, which is the total frequency of 42, it is going to be 42 plus 1 over 2. So there we can just simply use the calculator direct. 42 plus 1, that is 43, or you can just add 42 plus 1, then divide by 2. So this will give us 21,5. So the 21,5 is actually representing the position of the median value, which is our Q2. So what you're going to do is to add up the values up to the value of 21,5. Where actually are we going to obtain 21,5? You can add from the bottom, from the top here going down, or you can add from the bottom going upwards. So it depends with the way that you want. Okay, so I'm just going to do both methods so that we can check if we are obtaining the exact median value. All right, so our Q2 in this case, let's check the position where we are going to obtain 21,5. All right, So we are going to add, let's take these values aside. Remember, we need 21,5. So let's add, let's start from the top. Okay, we are going to start from the top here to bottom. All right, so the first one, that's a 0 here, so there's no effect. 3 plus 4, that is a 7. We are still below 21,5. We add again, that's plus 5, which is 12. After 5, there is 3, which is 15. So you're supposed to add all these. So that will be a 6 here. So if we add a 6, that is 21. We are still below 21 because remember, we need 21,5. So we are still below 21,5 and we are at this value, which is 6. All right. So the next value that we're supposed to add is a 0. But if we add a 0, there is nothing that you're going to have. All right. So the next value that we're going to add is a 7. So from this 21, if we add a 7, that's definitely above, which is 28. It's above 21,5. So which means we are actually obtaining the 21,5 position between these values, between these 6 and 7. That is where we obtained the 21,5. So the values that which corresponds with 6 and 7 are the values which we have here. That is 5 and 7. So we are going to add these two values, 5 plus 7 divided by 2. All right, so 5 plus 7 divided by 2, that will be the median value, which is 5 plus 7. Then we divide by 2, which is a 6. So this is going to correspond with 6. So that means the median mark that was obtained was 6, if it was 6%, if it was what, but that was the 6 that we have in there. All right, so that was actually the question 1.4. And on the last part of the question, which is 1.5, we are now asked to draw a box and whisker diagram for the data that we have. So we need to draw a box and whisker plot. Remember, if we are dealing with this information, let's check if I am having that in the answer space that I'm having here. All right, so we actually do not have that here. All right, so let's check if we can have that page. All right, so let's continue from this part. If we are to check, let's see, we have got our number line, which was given from 0 up to 10. All right, so from this, what you need from the box and whisker plot, remember, we need 5 number summary, which is the minimum value. So we need the minimum value here. Then we need the lower quartile, which is Q1, the median value, which is Q2, the upper quartile, which is Q3. Then we also need the maximum value. So these are the values that we are going to apply on this part. So the minimum value, like we had on the range there, we already saw the minimum value. Remember, the minimum value which was scored is a 1. So which means we've got 1. Also, the maximum value here, that's a 9. So we've got minimum value, which is a 1 here. Then the maximum value, which is a 9. All right. So Q1, that is, okay, let's see Q2. We calculated Q2 before. We calculated this, if I'm not mistaken, we calculated Q2 here. All right, remember, we calculated Q2 and we got a 6. So this one, we have it, that's a 6 here. So we are going to have a 6. So we are left with the Q1 and Q3. All right, so where are we going to have Q1 and Q3? So remembering that to find Q1, that is the lower quartile, so it's actually a quarter of the distribution, which is n plus 1 over 4. So that is the position that we need. Remembering that our n is the total distribution, which we said it's 42. So we are just going to add 42 plus 1 over 4. All right, so let's check what you're going to have from the calculator. 42 plus 1, that is 43. Okay, if we divide by 4, we are going to obtain a decimal of 10,75. So we need the 10,75 position, where that's where we are actually going to have our Q1. All right, so let's check from the table that we have here. Remember, we need 10,75. Remember, I still remember I was supposed to explain the other method here. Okay, we're going to do that another way. I still remember on Q2. Okay, anyways, let's see. We said we need 10,75 position. So we are going to add, this is Q1. So you add from the top going downwards until you obtain 10,75. Okay, so if we add 3, and 4 here, that's a 7. All right, so let's just be using our calculator for the benefit of doubt. So this is a 7, which is still less than 10.75. Remember the value that we need, we are still less than 10.75. Okay, we add the next value, which is 5. All right, so if we add a 5 here, that's 12. So as you can see, 12 is actually greater than 10.75. So that means we are obtaining 10.75 in this value of 5, which corresponds with a 3. So the median, the Q1 that we need is a mark that we need. So we are taking the value from the marks here. So this number in this column, it corresponds with 3. In this row that we are given, it corresponds here with a 3. So that is the one that we are going to have on our Q1. So which means our Q1 is actually equivalent to 3. So we are having a 3 here. Then we move on to Q3, just like what we did on Q1, but remembering that Q3, that is n plus 1 we are now having n plus 3. That is the maximum. All right, so from this information, if we are to add everything, what are we going to have in this case? Let's write it like this. This is n 3/4 like that. So we're going to have 3 being multiplied to n plus 1 of the distribution that we have. That is, remember, we've got 42 plus 1 over 4. All right, so that means we are going to have 3. Okay, let's just put a fraction so that it can be easy. So it's 3 into 42 plus 1, which is actually 43. 3 times 43. Okay, everything over 4. So this is going to give us 32.25. So where are we going to obtain 32.25, the position for 32.25? So I'm just going to add just like what we had. All right, let's get back to this here. So remember, here we were now at 10.75. So just going to continue from there. We are now at a value which gives us 10.75, which was at this value here. So which means we're going to add until we get 32.25. All right, so let's see what we are going to have. We've got 3 plus 4 plus 5 plus 3 plus 6. All right, we are now at 21, which means we are still less than, plus 7, which is 28. We are still less than, plus 9, which is 37. So as we can see here at 9, we have exceeded because we are now at 37. So this is where actually we are having our 32.25 in this case. So at this value, it corresponds with what? It corresponds with 8. So that is the value that you're going to take. So actually, there are so many ways that we can do, but I'm actually showing where actually it was taken from. So these are the values that we need on the box and whisker plot, knowing that the minimum value is 1. So we are going to represent our 1 here. So that's where we have our 1. Then the box is going to cover Q1 up to Q3. So we have got 3 here up to 8. So that's where we have our 8 here. So that is, it is going to be, no. This is now ugly. All right, so let's just see how it is going to look like later on, guys. Here you have to be very, very sensitive when dealing with this pen. Okay, anyways, we are going to have something like this, but you're supposed to draw a nice box there. So this is our Q1 here, which corresponds with 3. So it must correspond with 3. And Q2 corresponds with 6. 6 is somewhere here, so it must correspond with a 6 down here. So that's where we are having our Q2. Then Q3 is at 8. So this value corresponds here at 8, which is our Q3. Then the last one is 9, which is the maximum value. So at the maximum value, we are going to represent with a 9. Then we join the whiskers. So that is what we are going to have at the end. So that is our box and whisker plot from 1 up to. So as you can see here, this is our minimum value. So we put our minimum value here, and that's our maximum value. All right, so this is the maximum value, which corresponds with 9, minimum, which corresponds with a 1. So that's 3 marks for you guys. So like I said, there are so many ways of taking the values. So it depends with which way do you actually want to work with there? So as we are moving on, we are going to explain other methods or other ways of answering or taking values there. All right, on question 2, we are given that in the diagram below, we've got the point P, 0 point Q, 6, 3, point R, which is 9 minus 2, which are the vertices of a triangle. Say that PQ is equal to QR. Okay, from P to Q, it's equal to Q to R. Okay, so these two, they are equal. All right, so these two, they are equal. Then we are given that PQ is perpendicular to QR. Okay, PQ in PR and QR, yes, they are perpendicular here. That's a 90 degrees there. T is a point on PQ such that T is the midpoint of PQ. So T here is the midpoint. So we are given T as the midpoint. Then we are given S is the point of intersection, all right, of QR or RQ, and the x-axis at this point is a point of intersection. Then we are given that V is a point on the x-axis, all right, that is a point V here. All right, say that QSV is 121 degrees. Okay, so this V is just there for the angle. Then QPS, QP to S here is angle theta, the one that we are given. All right, so that's the information that we are given. Then from this information on 2.1, we are asked to determine the 2.11, the length of PQ, leave your answer in said form. So in said form simply means leave your answer under the square root, like square root of A. All right, so this is PQ, the length, remember from the points that you're given, we have got P here and we've got Q. So to calculate this length, okay, you can just even use this space here. So this is 2.11. All right, so the point P is given as 10 and the point Q is 63. So we can even name this as X1, Y1, and this as X2, Y2. So knowing that the length of PQ is going to be given as the square root of, must know this formula, guys, X2 minus X1 squared plus Y2 minus Y1 squared. So you can even use, you can start with Y, it's still one and the same thing. You can start with Y2, or you can even start with X1, it's still one and the same. So that means the length of PQ is going to be equivalent to the square root of X2. That is, our X2 is 6 and X1 is 1. So it's going to be 6 minus 1 squared plus Y2, which is 3. Y1, that's a 0 there, so it's going to be 3 minus 0 squared. All right, so that is the length that you're going to have, or you can, it depends with the way that you have numbered the points. If you have used this as X1, Y1, X2, Y2, then it means you're going to have a vice versa of the points, but the answer is going to be the same. So we are going to have the square root of, all right, let's just take this down, guys, so that we can do this. Okay, so from this point, you are going to insert the values that you are given. So it's the square root of, then you can put brackets, that's 6 minus 1. So you put 6 minus 1 squared plus 3 minus 0, which is 3. Or you can even write 3 minus 0 squared. Still, you are going to obtain the same answer, which is square root of 34. So that is the square root of 34. So that is the length of PQ. So the length is measured in units. So you can just write square root of 34 units as the length. So since we are given that our answer is supposed to be in said form, that is under the square root, you're going to leave your answer under the square root. So that was actually 2 marks for that. 2.12, the gradient of PQ. So taking note, we still have the points P and the Q there. So remembering that the gradient is given as, so this is 2.12. So the gradient of PQ, that's the change in Y over the change in X. All right, so we can have it as Y2 minus Y1 over X2 minus X1, which is Y2 here. According to the layout of my points, Y2 is 3. So it's 3 minus Y1, which is a 0 over X2, which is 6, and X1 is 1. So it's 6 minus 1. All right, so from there, we can obtain the gradient. You can just use your calculator here. 3 minus 0, which is 3. Then 6 minus 1, that's a 5. Or you can just use your calculator direct. We are going to obtain 3 over 5. All right, so that was the gradient of PQ. All right, sorry for that. I Okay, it's supposed to be like this. Let's see the other part of the question on 2.13, the coordinates of t. T, before we are given that t is the midpoint of PQ. So that means t is simply going to be determined using the midpoint concept. Okay, so remembering our midpoint, so this is 2.13. So I said t is actually the midpoint of the given point. So for you to find the midpoint, you add the values of x together. That is x1 plus x2 over 2. You add the values of y together. That is over 2 again. All right, so that is actually the point t. So if we are to check from P and Q here, our x1, that is 1, our x2, that is a 6. So it is going to be 1 plus 6. All right, that's x1 plus x2, 1 plus 6 over 2. Then we move on to y1 plus y2. You're going to add y1, which is 0 plus y2, which is a 3. So it's going to be 0 plus 3 over 2. All right, so that's actually the midpoint for the point t. So on your calculator, you can just add, but this is 1 plus 6, guys, which is a 7. So this is direct 7 over 2. Then 0 plus 3, which is 3 over 2. Or you can use your calculators too, it's fine. You're going to obtain the same answer like the one that you have. Or you can even separate the points, work them separately, or you can even work from the point direct as what we had from this one. So that was our 2.13. Then on 2.2, we are now given calculate, that is calculate the 2.21, the area of triangle QTR. Okay, let's check triangle QTR. That is from Q here to T and to point R. Okay, if we are to check the triangle that we are calculating the area, we can see that this is actually a right-angled triangle. All right, so that's a right-angled triangle in this case. So for us to have the area of a right-angled triangle, so let me just write the formula so that we can take the points later on if there is a need of taking the points. All right, so that is 2.2 or 2 point what? This is 2.2. All right, let's check again. So that is 2.21. All right, so we have got 2.21 here. 2.21. So we are calculating the area of the triangle. So we saw that that was a right angle triangle. So for you to obtain the area of a right angle triangle, we know that the formula is actually equal to half base times the perpendicular height. So that is the concept that you're going to have. So our area is going to be equivalent to half of the base times the perpendicular height. All right. So from half base of the perpendicular height that we have, which is the base and which is the perpendicular height? Let's check again on our triangle. Okay, so this is our triangle. We can let our base to be equal to QR. That is, we can let our base to be equal to QR here from Q to R. All right. Then the height from Q to R. So T to Q, sorry. This is T to Q and Q to R. Okay, so we've got QT and QR, the QT and QR. So we are going to have our area as half multiplied by QT times QR. So that is half base times the perpendicular height. So do we have QT? Do we have QR? That is the question. QT is supposed to be taken from the point Q and the point T. Remember, we calculated the point T now is 7 over 2, 3 over 2. And also the point Q is there is 6, 3. So I'm just going to take these points aside. So point Q is 6, 3. So let's just have our points aside here. So we've got point Q here, which is 6, 3, and point T, which is 7 over 2. So that is 7 over 2, 3 over 2. All right. So that means we are supposed to calculate the length from here. And also we've got the point R. Let's just take our points at once. Point R here is 9 minus 2. So that is 9 minus 2. So let's just have our points at once here. So that these are the points that you're going to use actually. Okay. So let's start with QT. For us to find the length of QT here, we are going to have the same formula. Remember the formula that we had But there is something about QT. Okay, there's something about QT. Let's just check to the diagram, because here we are given that T is the midpoint. So we can calculate the length, but we are already having this part that T here is the midpoint. So it actually means the distance from Q to T is the same as the distance from T to P. So that is actually from Q to T, it's half of the whole distance from Q to P. And we calculated that PQ previously here, PQ was 34 units. So this one, we are just going to have the half of that 34 units. There's no need for us to calculate it again. So we are saying QT is equivalent to, okay, let me just change the marker here. QT is equivalent to half of the whole line that we had, which is a PQ. All right, so if it is like that, then we are just going to take PQ, which is the square root of 34. All right, so you can leave it like that. That is the length QT. So we need QR now. QR, there is no way or no concept that we can use. So we are supposed to calculate our QR, or we can check again. Before that, guys, let's work with the diagram. Okay, remember what we said before here. All right, let's get back here. PQ is equal to QR. So we are having QR and PQ equal. So that means it is going to remain as the square root of 34. So there was no need for us to even list these points down. All right. So anyways, for just exam sake, we have learned something also that if this information was not there, therefore we were going to work with the points to calculate the length from these points that we have, QT and also QR. You calculate the length from there. But here, it's an advantage because of the information that was given. So that means the area of the given triangle is going to be half multiplied to QT, which is our QT. Remember, we said it's half the square root of 34 times the square times QR, which is the square root of 34 again. So that is where we are going to obtain our answer from. So this part, we can just use our calculator direct. So let's see, that is 1/2 multiplied to 1/2 times the square root of 34. So this is 1/2 square root of 34. Whatever that we have here, we multiply again to square root of 34, which is 17/2. So our area is going to be 17/2. These are square units, so you can write square units like this, or you can write in words, or you can even write your answer as a decimal. If you convert, that is 8,5. So this can be 8,5 square units. So you can even write it like square units, or you can write it square units like that. There are so many ways that you can present the square unit concept. So that was 2.21, which was the area of the given triangle QTR. Okay, let's check the 2.22, the size of theta with reasons, and that is actually 2 marks. Do we need any information? Okay, let's just check from our diagram. Okay, yes, an advantage, guys. Let's check on our diagram what we have. If we can check properly, let me remove this part. We have used this part here. If we can check from our diagram here, we can see that there is a 121 degrees that is given here on S. So using different formats, you can calculate this angle S, which is inside the triangle. You can calculate this angle. Then, since we know that angles on a straight line add up to 180 degrees, so you simply have to subtract. Then from there, we can add this angle of 90 degrees and this angle that you have determined here. Subtract from 180, you can obtain theta from triangle PQS. Remembering that angles in a triangle add up to 180 degrees. Okay, so there are actually many methods. I'm going to explain at least 2 methods here. Okay, so I'm just going to utilize here this space here. So that is 2.22. So the first thing, we can calculate the angle at S, all right? The angle at S here, which is inside the triangle, so that PSQ, which we said is 180 minus 121, angles on a straight line add up to 180. So you're going to subtract, so that's PSQ. Okay, let's subtract and see what you're going to have. 180 minus 121, 180 minus 121, that is 59. So this angle is going to be 59 degrees inside the triangle. You're going to have 59 degrees. Okay, so that's angle PSQ. All right, so angle PSQ, let's write it here. Angle PSQ is equivalent to 180 degrees minus 121, which gave us 59 degrees. So here it's actually angles on a straight line. So we are dealing with angles on a straight line. That's the reason that you're having here. So if we have angle PSQ as 59 degrees, therefore the theta that we need in this case is going to be equivalent to theta is going to be equivalent to 180 degrees minus the two angles inside the triangle, which is this angle of 59 degrees and 90 degrees. So you're going to subtract 59 degrees and 90 degrees. So it's 59 plus 90 degrees together. So that will be the angle theta. So we are referring to angles in a triangle adding up to 180 degrees. So it's 180 minus 59 plus 90 degrees, which is 31 degrees. So this angle is going to be equivalent to 31 degrees. Okay, like I said, this is not the only way that we can actually use. There are so many ways. We can check here from our diagram that the 121 degrees that we have, it's actually equivalent to the sum of these two angles, which is theta and 90 degrees. Remembering that exterior angle is equal to the sum of the two opposite interior. So 90 and theta, they are the opposite interior. They are equal to 121. So you can actually formulate an equation that theta plus 90 degrees, all right, theta plus 90 degrees is equal to 121 degrees. Thus, the exterior angle is equal to the opposite sum of the interior. So to find the theta, we are just going to simply subtract 121 degrees minus 90 degrees. If we transpose plus 90 to the other side, that's a negative. So theta is equal to what? 121 minus 90 degrees, that is 31. So as you can see, you're obtaining the same angle of 31 degrees. So this is it was actually easier from this way, but there are so many ways that we can actually use. All right, let's check the 2.23, calculate the coordinate of point S. All right, so from this information that we have, the point S, let's check where do we have the point S here. All right, so if we are to check, okay, that's somewhere here, that's our point S here, so here. So there are so many ways that we can use. It's a point of intersection, and also this point S is actually the x-intercept. All right, so some of these informations, they are not even necessary. Let's just remove some of these information that we have. So the point S that we see is actually the x-intercept of the line QR. If we are to check the line QR here, X is the point S here is the x-intercept, where we know that in the x-axis, y is equal to z. So if we can have the equation of QR, it's going to be easier for us to find the point S, because we can simply substitute y to be equal to 0. So we need the equation of the line QR. So how can we find the equation of line QR? Let's just use the space here. This was 2.1. Let's just check the equation again, guys. All right, this is 2.23. All right, 2.23. So like I said, that is 2.23. So like I said, we need the equation of the line QR. Equation of the line QR. So QR is a straight line. So we know that the equation of a straight line is equivalent to y is equal to mx plus c. So we actually need the gradient of the line PQ, or of the line QR. So to find the gradient, we can use the points, that is the point Q and the point R here. Or we can check from this part here. I want you to see something from this part. We have got the gradient of PQ here, which is the gradient of PQ, that was 3/5. So what we know is that from the perpendicular lines, because these two lines, they are perpendicular. So the product of the gradient of these two lines must give us a -1. So using advantage of the gradient of PQ, we can calculate the gradient of QR, or you can just take the points as they are, the point Q and the point R. You calculate the gradient just like what we did on PQ. You're going to obtain the same answer. All right, so using this concept of perpendicular lines, say the gradient of the line QR here, okay, so this is the gradient of line QR multiplied to the gradient of the line PQ, which it is perpendicular to, it must give us a -1. That's what we have when the two lines are perpendicular. So that means QR is the one that we need. So it's going to be the gradient of QR multiplied to the gradient of PQ, which was 3/5. Take note, the gradient that we got here, it was 3/5 from this point. The gradient is 3/5. So you're going to multiply by 3/5, then you equate to -1. So to find the gradient of QR here, you are simply dividing by 3/5. Okay, so by dividing by 3/5 to the other side, it's -1 divided by 3/5. Let's see what you're going to have. That is -5/3. So that is the gradient of the line QR. So if we have got the gradient, then we can simply substitute into the format of the equation that we said y is equal to mx plus c. So it means y is equal to m, which is the gradient of -5/3x plus c. So to find the c, you substitute any of the given points from the point Q and the point R. Just substitute any one of these points. We've got point Q, we've got point R here. So I'm just going to take point Q, which is 6, 3. All right, so the point Q is 6, 3. So like I said, you choose any point of your choice. So I'm going to take the point Q, 6, 3, where we've got X and Y. So X is 6, Y is equal to 3. So in place of Y, we substitute 3 is equal to -5/3 times the value of X, and our X in this case, that is 6 plus C. So you're supposed to find the value of C. So you can even simplify -5/3 times 6, so that you just see which value are you obtaining there. -5/3 times 6, that is -10. So 3 is equivalent to -10 plus C. So you can transpose the -10 to the other side, that will be a +10. So we are going to add 3 plus 10, which is equivalent to 13. So 13 is equal to C, or C is equal to 13. So if C is equal to 13, therefore the equation is going to be y is equal to m, which is -5/3x plus c, which is a +10. So that's what you're going to have on the equation. So just cross-check also with me, guys, if we are obtaining the same thing. If there is any mistake or any error, let us know, guys, so that we can revisit that question. So now we are going back to saying the s that we have, since we now have the equation of this line, and we said x is actually a point which is the x-intercept, where we know that y is equal to 0. So you're just going to substitute y is equal to 0 now to find the value of x at that point, since it is the y-intercept. So if y is equal to 0, that means 0 is equal to -5/3x plus 10. So you're supposed to find the value of x. So to find x, just transpose -10 to the other side of the equation. +10, it will be negative. So it's 0 minus 10, which is -10 is equal to -5/3x. So to find x, we are going to divide by -5/3 on the other side. And that will be -10 divided by -5/3. So it's -5/3. Let's see what you're going to have, which is a 6. So x is equivalent to 6. So at this point, s, which is on the graph here, s here is equivalent to 6. X is 6. So therefore, the coordinate of s is going to be 6, 0, because we need the coordinate where we know that is supposed to be found by the value of x and the value of y. So therefore, the point s is going to be 6, 0. So that was actually the concept that you had. So like I said, there are so many ways that we could have worked out this question. So if you are having another way, let me know so that we can also work on that concept with others. as we are revising, guys. This is a revision as we know. All right. 2.3, determine with reasons the gradient of the line through T and the midpoint of QR. So we need the gradient of the line which is going to pass through the point T and on the midpoint of QR. All right. So let's check from our information that we have, guys. I think this I can just erase some. Okay, we still need some points here. Remember, we have got the point T, which we calculated before. Point T, the point T here, which was 7/2, 3/2. Here we calculated the point T. So you're going to take that point T. So this point is going to pass the point T, and we have that point T. So let me just erase some of the information, guys, so that we can be able to calculate this properly. All right, I'm just going to erase this part here. It's going to be enough. All right, so we are going to have our 2.3. We say the point T we already have because it passes through the point T. And the point T we say is 7/2 and 3/2. All right, so and the midpoint of PR, we never calculated the midpoint of PR. So that means we are supposed to calculate the midpoint of PR. So the midpoint of PR is going to be taken from the formula is not going to change, guys. Remember the formula, you add the values of X together and divide by 2. The same thing, the values of Y together and divide by 2. So that is actually going to give us the midpoint of the point R. Okay, so from this information, we have got the point P, we've got the point R. All right, we have these points here. The point P is there, that is 6, 3. That is our point P here, 6, 3. And R is 9 minus 2. So take note, this is the point that we need. All right, P and R, not Q. P here is 1, 0. P, we are referring to the point P, guys. Take note, point P, 1, 0. And R is 9 minus 2. So we've got the point P, which is 1, 0. Okay, all right. That is a 1, 0 here. And the point R, which is 9 minus 2. All right. So these are the 2 points that we are going to use to calculate the midpoint. All right, because it's supposed to pass through the midpoint of QR, of PR, maybe somewhere there. We do not know the point. So that is the one that we are supposed to calculate. So there are so many ways actually that you can use to calculate this. All right, so let's substitute the information so that we can calculate this value, which is the midpoint. So by inserting the values, we can just name our points. This is X1, Y1, this is X2 and Y2. So that means the midpoint of PR, midpoint PR is going to be X1, which is 1 plus X2, which is 9. So I'm already adding together here. That's a 9, guys, over 2. Y1, that's a 0 plus Y2, which is a -2 over 2. So that means the midpoint of PR is going to be 1 plus 9, that's 10 over 2, which is 5. Or you can just use your calculator. That's 5. 0 plus minus 2, that's 0 minus 2, which is -2 over 2, that's -1. So this is going to be -1. So we have the midpoint and we have the point T here. So the question is for us to calculate the gradient. So for us to have the gradient, we are going to use the formula. So the gradient, that's our M, or you can just write it as a gradient. All right, so here I'm just going to write it as gradient. So remembering the formula for the gradient, we talked about this formula before for the gradient, which we said is the change in Y over the change in X, which is Y2 minus Y1 over X2 minus X1. So that means the gradient of that particular point is going to, points that we have is going to be, we can name our points, point T, we can name it to be X1 and Y1. Then PR here, the midpoint of PR, we can name it to be X2, Y2. All right, so that's y2, which is -1. So you're gonna have -1 minus y1 here, which is 3/2. Okay, everything over x2. X2 is 5 minus x1 here, which is 7/2. So that is going to be the gradient of the line. So you can even use your calculator direct to find this value here. So you just need a fraction. So you've got -1 minus 3/2. That's 3/2 here, over 5 minus 7/2, so it's going to be 5 minus 7/2. So it's going to be 7/2 like this. All right, so that is the answer, which is -5/3. So we are going to obtain -5/3. So this was actually going to be taken from the concept that we, so like I said, there are so many ways that you can use. So but I think with what we have or what we are used to, guys, this was actually going to be this is maybe a lot. So sorry for that, guys. I'm actually sharing the screen, so everything is displaying any movement. So sorry for that. So there can be so many ways. So as we are revising, actually these questions, they are very basic and they are repeat now and again. So definitely we are going to work different methods. So we are going back to the, let's get back to the other part of the question, which is on question 3. So on question 3, we are given the diagram. In the diagram below, we are given triangle PQR is right-angled triangle with QPR 90 degrees. So QPR here is 90 degrees. That's a right angle here. So we put our 90 degrees. Okay, on 3.11, use the sketch to determine the ratio of tan 90 minus R. Okay, that's 1 mark for that. All right, let's see. Let's see what do we have here. So this is actually 3.11. I can just even use like this space here. So we are given to find the value of tan 90 degrees minus R. So remember your identities, guys. You're supposed to somehow play around with your identities. So this we can work with it direct, because tan 90 degrees minus R is actually equivalent to cot R. So this is the same as cot R, where we know that cot is the inverse of tan, which is given as 1 over tan R, like that. So by finding tan R, it means we can actually find this value. And remember from your SOHCAHTOA, so there are so many ways of presenting this, but I usually use the SOHCAHTOA here. So tan R is actually on tan here, which is opposite over the adjacent. So this tan is equivalent to the opposite over the adjacent. So that means the whole process or the whole expression that we have is equivalent to tan 90 degrees minus R. Everything that we have, which is equivalent to 1 over tan, which is the opposite over the adjacent. So it's going to be 1 over opposite over adjacent of R there. R is here. This is our angle R here. So which one is the opposite and which one is the adjacent? So according to R, this is the opposite, the one that faces R here, direct with R, that's the opposite. So we have the opposite and the adjacent, where R is adjacent to 90 degrees. So that is the adjacent side. All right, so that means we can substitute from this information. That is 1 over tan R, which is opposite over adjacent, and our opposite is PQ. So it is going to be PQ over the adjacent, which is PR. So that is PR like that. So remember, guys, that if you are dividing, 1 divide by simply means the inverse of. So we are simply finding the inverse of PQ over PR, which is simply inverting the fraction. So you're simply inverting the fraction, which is PR over PQ. Okay, someone can write these values as P corresponds with the small letter P, Q corresponds here with small letter Q, R corresponds with small letter R here. So if you are to write in that format, that means your PR here, PR is equal to Q. So it was going to be Q over PQ, PQ, which is R there. So you can write it as P over R. So it depends with the way that you have written it. So that was actually the process. So as you can see, guys, it's actually easier. So that was actually 1 mark for that. And 3.12, 1, 2, write down the trigonometric ratio equivalent, or which is equal to QR over QP. If you are given this type of equation, it actually depends with the way that you want to write it down. So this is 3.12. We need the ratio that is equivalent to QR over QP. So from this part, it depends with where you're going to start. Let's say you are referring to the angle R here. QR, according to angle R here, this is our QR here, of which our QR does not change. That's the hypotenuse. Whether you are referring to Q or you are referring to R, the hypotenuse does not change. So QR is definitely the hypotenuse. And the QP, this is QP. So according to R, QP is the opposite. So this is the hypotenuse over the opposite, which is a ratio which is taken from the vice versa of tan, of sine. Remember, sine here, it's opposite over hypotenuse. And this is the vice versa now, which is hypotenuse over the opposite. So which is the vice versa of sine? That is a cosec. Remember that cosec of R is equivalent to 1 over sine R. So what made us to write hypotenuse over opposite? It was actually the inverse. It was 1 over opposite over hypotenuse, like this, of which opposite over hypotenuse is sine. So the moment you introduce 1 over, it is the inverse, like what we did, guys. Inverse, we said simply invert these two. So that is hypotenuse over opposite. So if it is 1 over sine R, which is sec R, so that is actually the equivalent. So that is the answer here was supposed to be cosec R. So like I said, it depends with which direction are you taking from. Are you taking from R or from Q? If you are taking this from Q, this is Q. According to Q, this QP is no, QR is not going to change. QR is going to remain as the hypotenuse. So this was according to R. So according to R here, according to angle R. All right, so let's see according to angle P. So according to angle Q, according to angle Q, what do we have? So according to angle Q, if we are to take back our ratio of QR over QP, the hypotenuse, like I said, it is not going to change. It's going to remain as hypotenuse, but QP is going to change. According to Q here, QP is the adjacent, because we have got angle Q and 90 degrees. They are adjacent to each other. So this side is going to change to be the adjacent. So it is now hypotenuse over the adjacent. So let's take, where do we have hypotenuse over adjacent? Hypotenuse over adjacent is not there. We actually have adjacent over hypotenuse from cos. Cos theta is equal to adjacent over hypotenuse. But that one that we had, it's hypotenuse over adjacent, which is the inverse, or 1 over cos of theta. So in this case, it means that this ratio was simply taken from 1 over cos Q, because cos Q is the one which gives us adjacent over hypotenuse, but this is the inverse. So if it is 1 over cos Q, then we know that 1 over cos is equivalent to sec. So that is sec Q. So take note, guys, of your 6 trigonometric ratios. 1 over cos is equivalent to sec. So it is going to be sec Q. So like I said, it depends with the direction. So you can have this. So there are so many ways that you could have obtained these answers. All right, let's check the other part, which is 2.2, 3.2. So on 3.2, we are given that S is a point which is negative 3, 4. That is a point on the Cartesian plane side that OS makes an angle of theta with the positive axis. So this is the theta here. So what does it mean? It simply means that here we can have something like this. It's actually a triangle that you can formulate from this part here. So S is the value of X. We've got X, which is negative 3, Y, which is negative 4. So it means the X, this is your X-axis. So from this point to this point, that's where we have got our negative 3. So it means we have got negative 3. Then the value of Y, this is the Y-axis going down. that is your -4. We are going down. All right, so this is actually a right-angled triangle. Okay, so that's the information. What does this point actually mean? So the angle inside here is actually the acute angle. You can write it as alpha, or you can write any angle of your choice there. That is actually the acute angle. Then the obtuse, then the other angle that we have, which is the theta, which is the one which falls into this quadrant. So there's no need for you to actually use the concept of all students take calculus concept, because you are already given in form of a triangle. It gives you the answers that are direct. All right, so anyways, let's not waste time. Let's see the question. The first part of the question was calculate without using a calculator the length of OS. So we need the length of OS on 3.21, the length of OS. Okay, what are you going to do to find the length of OS? Okay, 3.21, we can even utilize this space, 3.21. So to find OS, we can see that from the diagram, that is a right angle triangle that we have now from O to S here, that is the hypotenuse. Okay, so we've got the other side, which is 3, -3, and -4. So we know that hypotenuse squared, okay, we can take it from hypotenuse squared is equal to side squared plus side squared. So to find h, you simply introduce the square root. So you've got h. So that means s is equivalent to the square root of the shorter side plus the other side, which is the shorter side. So OS is equivalent to the square root of a. In this case, we can write it as x. Okay, this is x squared, y squared, because this is x and this is y. So it's going to be -3 squared, -3 squared plus the y value, which is -4 squared. Okay, so that is going to give us the length of OS. So we have got the square root of -3 squared is same as 3 squared. Okay. So it's bracket here. -3 squared plus a bracket -4 squared, which is going to give us 5. So OS is actually 5 units and it's a positive. So from O to S here, we have got a 5. So always the hypotenuse is a positive. It cannot be a negative. It's always a positive. So take note of that. All right, so that was the length of OS, simply 2 marks, applying the Pythagoras theorem. The other part we are given on 3.22, find the value of sec theta plus sine squared theta. Okay, so what can we do from this part? Okay, let's just write it aside. So this is 3.22. So we need the value of sec theta plus sine squared theta. All right, so sec, remember from our 6th trigonometry, sec is equivalent to 1 over cos. So it's like 1 over cos theta plus sine squared theta can be written as sine theta squared. Take note, it's not sine theta squared like that. This is wrong. All right, so it's sine theta in bracket, then you square everything. All right, so what you simply need is to take, guys, from your soccer tour that we had from that part. All right, so you can even rewrite it down here. So this is soccer tour here. All right, so cos theta is actually equivalent to adjacent over hypotenuse. So that's cos theta adjacent over the hypotenuse. So according to the theta that we have, you are going to use this angle inside of the triangle. That is the one that you're going to use. So according to this angle alpha, that is the opposite side here. And the 3, the alpha and the 90, they are adjacent to each other. And this is the hypotenuse. All right, so we need the value of adjacent over the hypotenuse, which is adjacent is -3. The hypotenuse is a 5. So it's going to be -3 over 5. So this is going to be written as, remember, it's 1 over. So it's 1 over -3 over 5 for cos theta plus sine theta according to the ratio of sine here. Sine is opposite over hypotenuse. So that means sine theta is equivalent opposite over hypotenuse. So according to our diagram, the opposite side is -4. The hypotenuse is 5. So it's -4 over 5. All right, so this is going to be -4 over 5. But don't forget that the sign is being squared. So it's going to be to the exponent of 2. So that's what you're going to have. Remembering that we talked about this, that 1 over simply means the inverse of. So this is going to be the inverse, which is -5 over -3. Or you can even use your calculator to cross-check that one. That's 1 divided by -3 over 5. That's the inverse of that number, which is negative 5 over 3. So this is going to be negative 5 over 3 plus negative 4 over 5 squared. We can square that one. Okay, let's just put in our brackets, negative 4 over 5. Then we square everything, which is going to be 16 over 25. So this is 16 over 25. So if we add everything, what are you going to have? Negative 5 over 3 plus the answer that we already got previously, which is going to be negative 77 over 75. Is that so? Okay, let's cross check again. Negative 5 over 3 plus 16 over 25. All right, that's negative 77 over 75. So we put negative 77 over 75. All right, so that's it. Yeah, we can leave your answer like that. You can just leave your answer like that. It's fine. It's fine like that. All right. So on 3.3, determine the value of the following method using a calculator: cosec 45 degrees, sine 90 degrees, and tan 60. All right, so for this one, guys, you simply need to understand the special angles that we have from the triangles of, all right, from the angles of 60, 30, those special angles. So remember, we've got these triangles. I'm just going to present it here. When this is 90, this is 45, and this is 45. This side is going to be 1, and this one 1, and the square root of 2. And we have got this one, okay, depending with the layout. But as for me, I can use this as 60 degrees, 30 degrees. So we know that this will be a 2, this will be a 1, and this will be the square root of 3. All right, so these are the special angles that we have. So from these, we can determine any ratio of our choice. So let's take our identity, which is this ratio that you're given. We have got cosec of 45 degrees over sine 90 degrees times tan 60 degrees. Okay, knowing that cosec is given from the 6th trigonometry, cosec is 1 over sine. So this is actually 1 over sine. Okay, we've got 1 over sine theta. So we can write this as 1 over sine of 45 degrees. Okay, if it was sec, 1 over cos. Okay, cosec, 1 over sine. So this is 1 over sine 45, and everything we have got sine 90 degrees times tan 60 degrees. So this is actually the part of the numerator. This part is together here. So don't forget that it's one and the same thing. So 1 over sine from our identities, from our ratios, guys, we've got our, don't forget your SOHCAHTOA. So that's our SOHCAHTOA here. So sine 45 from this part that we have, we can see that sine is opposite over hypotenuse, and we've got 45 here. So we've got 2 of them. So I'm going to work with this one. So according to this 45 degrees, this is our opposite, and that's the hypotenuse. Okay, so opposite over hypotenuse, that's 1 over the square root of 2. So we are going to have our answer as 1 over the opposite over the hypotenuse of sine, which is 1 over the square root of 2. So it is going to be 1 over the square root of 2. So this is what you're going to have. Okay, everything over sine 90. So according to 90, we can't say this is the opposite, but we're supposed to know the value of sine 90. Sine 90 is equivalent to 1. Or you can even remember from the trig of sine, if you can check sine theta, it is from -1 up to +1. So that is at 90 degrees, we've got 1. At 270, we've got -1. So this one is a 1. Okay, times tan 60 degrees. Tan is opposite over the adjacent. And according to 60 degrees here, this is the opposite, and our adjacent is 1. So it's going to be square root of 3 times 1. So that is going to be the square root of 3. All right, so that's what you're going to have. So remembering without using a calculator, so you're going to have 1 over this. Remember, we said 1 over simply means the inverse. So it's going to be square root of 3, square root of 2 over 1. That is the inverse, square root of 2 over 1 like this, which is the same as square root of 2. So this will be square root of 2 over the same thing here, put 1 times square root of 3, which is square root of 3. So you can leave your answer like that, or you can rationalize the denominators, remembering that from the sets, we can rationalize the denominator here. We can multiply by the denominator, which is square root of 3 over the square root of 3. So by multiplying by square root of 3 is going to be square root of 2 times square root of 3. You multiply 2 times 3. Remember that if you're multiplying sets, the square root of a times the square root of b is same as the square root of ab under the square root. So this will be 2 times 3, which is the square root of 6 over square root of 3 times square root of 3, which is equal to 3. Square root of a times square root of a is equal to a. So this will give us a 3. So that is what you're going to have, guys, from the whole expression or from the whole trig that we were given. So yeah, it's simply, guys, we have to work with more questions. Yeah, let's try to revise as much questions as we can. It can actually help, guys. I'm telling you. All right, so let's check the question 4 that we have. So on question number 4, we are now given, can I just need to remove some of the things. On question 4, we are given that in the diagram below, ABC, ACD, ADE are right-angled triangles. So there's a right-angled triangle here, a right-angled triangle, right-angled triangle there. BAE is 90 degrees, BAC 30 degrees. Okay, so this is BAC here, which is the 30 degrees. All right. Then we are given BC 20 units and AD is 60 units. Okay, the 4.11, calculate the length of AC. All right. Where can we have the length of AC? Which part can we use? Okay, I want you to see that this is 4.11. I can even write it here. So this is 4.11. From AC here, from this triangle that we have with an angle of 30 degrees, we've got AC, this triangle. So using triangle ADC. So we've got triangle ABC, sorry, triangle ABC. So in triangle ABC, according to 30 degrees, we can see that our AC, okay, AC does not change because it's opposite to the 90 degrees, which is the hypotenuse, okay? But according to 30 degrees, this 20 here becomes the opposite. As you can see, it's facing each other here, so that's the opposite. So which ratio actually works with opposite and hypotenuse at the same time from your soccer tower? So back on our soccer tower, here we can see that opposite and hypotenuse, they are found on sine, opposite of hypotenuse. So what you simply need is to write the ratio for sine, where you know that sine theta is equal to opposite over the hypotenuse. So you take this way, opposite over hypotenuse. So if sine theta is equal to opposite over hypotenuse, therefore you can substitute the values because you are given the theta as the angle of 30 degrees. So sine 30 degrees is equal to the opposite, which is BC, with 20 units. So it's 20 units over the hypotenuse, which is the side that we are supposed to calculate, which is AC. So as you can see, we have formulated an equation with AC. So you can solve this equation. We can cross multiply because sine 30 is same as sine 30 over 1. So if we cross multiply here, this is going to be AC times sine 30, which is AC sine 30 degrees is equal to 20. So to find AC, we simply have to divide by sine 30 both sides. All right, so what are you going to have if we divide? That is AC is equal to 20 divided by sine 30. So from your calculator, you can find this value here, 20 divided by the sine of 30. Okay, the other thing, make sure that your calculator is in degrees. So my calculator, there is an error there, which is radians. So I have to change the setup here to degrees, which is 3. So make sure that your calculator is in degrees. Okay, so this is 20 over sine 30, which is sine 30 degrees. All right, like that. So we are going to obtain a 40. So AC is equivalent to 40 units. So that's what you're going to have. So which means from point A to C here, we have got 40 units. So you can even write our 40 on that part. Maybe it's going to help us to calculate another side. So it depends with the way that you're going to have, or you could have used this angle, because if this is 30 degrees, we can calculate the angle at C here. Remembering that angles in a triangle add up to 180. So you can simply calculate the angle at C, which is 180 minus 90 plus 30 degrees, which is 60 degrees. Or you can just subtract direct 90 minus 30 because these are complementary angles. So you can use 60 degrees, but when using 60, this becomes adjacent. So we are going to use the ratio for cos, the one that is got adjacent and the hypotenuse. So it depends. Okay, let's check 4.12. the size of CAD, that's C, A, and D. Okay, the triangle CAD is still a right angle triangle. And there are two sides that are given, which is the AC that we calculated now and the AD that we are given. So according to CAD, this is CAD, this angle here. This is the angle that we have. So according to this angle, AD is the hypotenuse, does not change. It's opposite to 90 degrees. So which means you have the hypotenuse. This is going to change according to the triangle that you are now dealing with. This 40, it is going to change because we are dealing with triangle ACD. So the 40 that we see is now adjacent. So angle A here, it's adjacent to the 90 degrees. So this becomes adjacent. So as long you have the sides, guys, the trigonometrical ratios, they are going to work. All right. Remember, we want to calculate angle CAD. Let's check the ratio that he has got. These two, which is, okay, let's just write down 4.12. We want to check the ratio which consists of the adjacent and the hypotenuse at the same time. And this is cos. Adjacent and hypotenuse is found on cos. So what you simply do is to insert the values on the formula. So this is what we have. We need cos theta. So cos theta is equivalent to the adjacent over the hypotenuse. So you can even write this as adjacent over the hypotenuse. So you can substitute, which is cos theta, which is the angle that we are supposed to calculate here, which is CAD, this angle CAD. So it's cos CAD. Cos CAD is equal to the adjacent over the hypotenuse. So the adjacent here is 40, the hypotenuse is 60. So it is going to be 40 over 60. All right. So that's what you're going to have. So to find the angle CAD, remember what you need is to find the angle CAD. You remove this cos here. But how do I remove the cos? To remove the angle, to remove the cos that we see so that we remain with the CAD, you write on the other side as arc cos. So it is going to be arc cos 40 over 60. So arc cos like that. So arc cos is on our calculator, which is shift cos. So it's simply shift cos like that. So that is arc cos. So it's arc cos 40 divided by 60, which is 40 over 60 like that. So you've got the angle, which is 48.189. If you round off to 2 decimal places, that will be 48.19. All right, so that is the angle that we are going to have in this case. So our CAD is going to be, we said 48. So that was 48.19 degrees. All right, so that was the concept for the angle CAD. So you can even write it 48.19. So here we put 48.19 degrees, just in case we might need this. All right. Then on 4.13, we are now asked to calculate the length of DE, and that was 3 marks, the length of DE. Okay, so this is our DE on this part here from D to E, this side here. So definitely we are going to work with triangle ADE. But in triangle ADE, we are just given a right angle here. We do not have any angle. But we can take advantage of the whole of angle A here. The whole of angle A is 90 degrees. It's a right angle. So these 3 angles, they add up to 90 degrees. The angle here, we can say A1, A2, and A3. These 3 angles at A, they add up to 90 degrees. So to find this angle, which is DAE or EAD, depending on the way that you want to take it, we are going to simply subtract the 2 angles that we are given from the 90 degrees, which is the right angle. All right, because we've got BAE as 90. All right, so that is what you're going to do first. At least it can help us, because if we have got an angle inside, it can be the easiest way. All right, so let's see what we're going to have. So you say this is angle DAE. All right, so we've got angle DAE. This is 4.13. All right, so angle DAE, which is actually our theta, is equivalent to 90 degrees minus the 2 angles which are part of that 90 degrees, which is 30 and 48.19. Okay, so it's 30 plus 48.19. We subtract these 2 angles from 90 degrees so that we can obtain the angle inside the triangle. All right, So from this, what are we going to have? 90 degrees minus the sum of the two, that is 30 plus 48.19. That is something like 11.81 degrees. Okay, so we've got 11.81 degrees. So this is our angle DAE. All right. So if DAE is 11.81, this angle here, if it is 11.81, we can take that as an advantage now to calculate DE, because there's an angle now inside the triangle here, because already there's a side that we are given here of 60. So that means we are going to have our 60 and the other side, which is DE. All right, so according to 11.81, this side that we see, which is DE, is the opposite. As you can see, these are facing each other. All right, then the 60 here is the adjacent. 11.81 and 90 degrees, they are adjacent to each other. So this is your adjacent. So you're supposed to find a ratio which is going to apply opposite and the adjacent at the same time. And according to this, opposite and adjacent is found on tan. So we are going to utilize the ratio for tan, which is opposite over the adjacent. All right, so that's what you're going to have here. So tan theta is equivalent to opposite over the adjacent. So if tan theta is equivalent to opposite over adjacent, let us insert the values, because we have our theta. Our theta is the angle, which is 11.81. So that means tan 11.81 is equivalent to the opposite over the adjacent. So let's check which one is the opposite, which one is the adjacent. So the opposite is the DE that we need, and the adjacent is the 60. So it's DE over 60 units. All right, so that is DE over 60. So with this ratio, we can be able to calculate DE by just cross multiplying, because this is same as over 1. So if we cross multiply here, that's 1 times DE, which is DE is equal to 60 times tan, which is 60 tan 11.81 degrees. Okay, just tan, or just write tan. All right, so that's our DE. 60 tan 81 is going to be 60 tan 11.81. So that's 11.81 in this case, which is 12.545. So if you round off, it is going to be 12.55. So this will be 12.55 units. All right, so we have the length of DE from this information. So that was actually a direct question. If we can check properly, but you just have to revise, guys, as much questions as possible so that it can be more direct than it looks right now. All right, on 4.2, we are given, so for x, for every one decimal place where x, okay, we are given an interval for x, that our x is supposed to be taken from 0 to 90 degrees. Okay, so sometimes they can give you from negative 180 to 180, from 0 to 360. So work out with the given interval that you have here. So from the interval of 0 to 90 degrees, we are supposed to calculate the first one, 4.21, which is tan x is equal to 2.01. Okay, let's just see. Tan x, so that is 4.21. Okay, so we are given that tan x is equivalent to 2.01. So as we know, guys, to find x, we simply have to find arctan of the given value here. Like I said, arctan, it can be written as arctan of the value 2.01, which is from your calculator is simply shift tan. Make sure that your calculator is in degrees. So it's shift tan, that's arctan 2.01. All right, which is going to be 63.45 and so on. But remember, you're given our answers to one decimal place. That is, we are given an instructive accuracy. So it's going to be 63.5. So x is going to be 63.5 degrees. All right, so since we are given that from 0 to 90, it was actually supposed to be like this: all students take calculus. So we are taking our answers in the first quadrant only. But if it was from 0 to 360, another answer was going to be taken in this quadrant of tan. So like I said, it depends with what you have. So here from 0 to 90, that is the answer. We just have one answer there. All right, let's check the other part of the question. That is 5 cos x plus 2 is equivalent to 4. All right, so let's take that's 4.22. We are given that we have got 5 cos of x plus 2, which is equivalent to 4. All right, so you can start by first changing or transposing here the 2 to the other side of the equation is going to be a -2. So it's 4 minus 2, which is 2. So we've got 5 cos of x, which is equivalent to 2. We can divide by 5 since it is multiplying both sides. So that's cos x is equivalent to 2 over 5. So to find x, just like what we did, is going to be arc cos of the value. So x is equivalent to arc cos of 2 over 5, or just use your calculator. You can even not present this part. All right, so from your calculator, shift cos 2 over 5 gives us 66.42 to 1 decimal place. That is 66.4. So it's 66.4 degrees. So that was the value. There from 0 to 90, that answer is going to work. On 4.23, cosec x over 2 is equivalent to 3. All right, so let's see. Let's even consider here. You can even use this space here. So this is 4.23. We are given that the cosec of x over 2 is equivalent to 3. So how can I simplify this? Before we talk of the cosec value, let's start by dealing with the fractions. We can remove the fractions by cross multiplying. So 1 and cos x and 2 and 3. 1 times cosec x, that is cosec x is equivalent to 2 times 3, which is 6. So remember that cosec is actually equivalent to 1 over sine. So here we can have it as 1 over the sine of x, which is equivalent to 6. And 6 is a whole number, which is same as 6 over 1. So that means you're supposed to find a new trig that is going to be of sine. So if you cross multiply here, that's 6 times sine x, which is 6. Sine x is equivalent to 1 times 1, which is 1. So you can divide by 6 both sides so that you remain with sine x. So sine x is equivalent to 1 over 6. So if sine x is equivalent to 1 over 6, so definitely we can have our x as the arc sine of 1 over 6. So this is the presentation that you're supposed to see on your calculator. All right, so the arc sine, which is the shift sine 1 over 6, is going to give us what? That is the answer there, which is going to be, oh, sorry, I forgot the bracket. Yeah, we're supposed to move aside. Okay, that is 9.59, but to 1 decimal place is going 9 is going to change 5 into 6. So it's going to be 9.6. So that's 9.6 degrees. All right. So that's what you're going to have as the angle. Yes, it's the smallest angle of all these angles that we determine. So that was 4.23. As you can see, guys, it's a matter of playing around with the trig ratios that actually can help you guys to work out as much as you can. So I actually encourage you guys to revise. All right, much questions. Okay, let's see the other part, which is 5, question 5. So that was actually a total of 15 marks on this question. All right. On question 5, we are given to consider the answer book here. All right. We are supposed to consider from the answer book. So we are given that f of x is equivalent to -3 tan x. 5.11, sketch on the grid provided in the answer book the graph of f. For the values, as you can see, your interval is 0 to 360, guys. Clearly show all the intercepts and the asymptotes and all the asymptotes. Okay, so that is actually 3 marks. So if you are not used to this graph, guys, if you're dealing with the graph of tan, you're supposed to know the graph. But if you are not used to this graph, therefore, I want you to know this. The graph of tan actually uses a separation of 45 degrees. The angles, they are separated by 45 degrees. So what you can do, if you do not know this graph, you can create a table. Okay, this is where you are supposed to have our graph. I just want to show you just for some of our friends so that we all understand what is happening. So you can create a table. You are given, this is a function. Okay, let's see how we are given it. We are given as f of x. All right, so this is our f of x, which is equivalent to -3 tan of x. So like I said, you can create a table having your values of x separated by 45 degrees. So you're going to have X and Y here, which is starting from 0. We've got 45, 45. So they are separated by 45 by 45. So you add 45 plus 45, which is 90. You add and so on. So that is 90 degrees. You move on to 90 plus 45, which is 135 degrees. 135 plus, so you simply add and add and add. So we've got 135 plus 45, which is 180 degrees. We move on 180 plus 45 up to 360. So this is 225 degrees plus 45 again. This is going to be what? 270 degrees. All right, we add 45 again until we reach 360. So that is 315 degrees. Then we add 45 again, which is 360 degrees. All right. So after inserting, you are going to insert the values from the calculator. That is when X is equal to 0. So what you simply do is that you are simply substituting -3 tan 0 like that. All right, which is S0. So you're going to obtain S0 here. You move on to 45. So it's -3 tan 4, and so on up to the last one. So this is -3. You move on to tan 90, but we know that tan 90, we do not have a value here. So that will be actually infinity. All right, where we have the asymptote. So you're going to move on to 135, which is a 3. Then we move on to 180. That's tan 180 here. Okay, that's 180 degrees, which is a 0 here. We move on to 225. That's tan 225. All right, 225 here, which is a -3. We move on to 270, which is an asymptote there, but let's just substitute so that we all learn what happens here, which is an asymptote. So if it writes an error like that, it means that's your asymptote. You move on to 315, that's 315, which is 3. Then you move on to 360, 360 here, which is a 0. So these are the values that you're going to determine or that you're going to have. So with the values, now you can indicate them on the graph. So the first thing that you need actually is to represent the asymptote first, which is the asymptote is found at 90 degrees here and at 270. So at 90 degrees, we have got the asymptote. So you can even represent with a broken line. So which means your graph is not going to pass at 90 degrees, and also at 270 degrees, it is not going to pass through these points. All right, so that's our asymptote. So take note, this is your 0 here, your 90, your 180, your 270, and your 360 here. All right, so there we are just indicating the points 0 and 3, that's 0 and 3 on top here. All right, sorry, that's 0 versus 0, guys. Where am I getting 0 and 3? This is 0 versus 0. Okay, then we've got 45 versus a -3. So 45 is in between. We've got 1, 2, 3, 4, 5, 6. So it's here in between. So this is 45 versus a -3 in between here. So this is your 45 degrees. All right. At 90, that's an asymptote. Okay. Then we've got 135 in between 90 and 180. That's 1, 2, 3. So this is your 135 degrees. So 135 is versus 3. So 135 is versus 3 here. All right. Then we've got 180 versus 0, 180 versus 0 here. 225 is in between 180 and 270, which is 1, 2, 3. That is 225. So it's 225 versus -3. At 270, it's an asymptote. 315 between 270 and 360, that's 1, 2, 3. That's your 315 degrees, which is versus 3. All right, then at 360, it's versus S0. So you need to know the graph, but if you do not know the graph, then you can use this concept. So what you're going to do is to join the points now from 0 to 3. So remember that from 0 to -3. So remember that we have got an asymptote there. So the graph is not going to reach the 90 degrees. Okay, the same thing, we join these points after the asymptote. We are going to join from this point of 3 to 0 to -3. So this one is going to be somewhere, something like this, up to 180. Then it goes down. Okay, it goes down to this point. Okay, somewhere like that. So it is not going to reach 90. It is not going to reach 270. Then the last piece is taken from 360 from this point to this point, going down like that. So that's where we're going to have the last piece of the graph. So this is the graph of tan, which is f of x is equivalent to -3 tan x. So you just write on one piece. You can write on this one or on this one. So that was actually the presentation that was required. So the question is asking you to just indicate, to just draw the graph. Okay, just draw the graph. Okay, so let's see the other part of the question. After drawing the graph, we are now given hence or otherwise. So hence is from that graph that we have. Write down the period of f. So actually the period of f is where we are having a full cycle. Okay, that's the first period of f. So for tan, the period is actually 180 degrees. Okay, if it is you're dealing with tan. If you are dealing with sine, 360. If you are dealing with cos, it's 360. Okay. B, the equation of h, which is h is a reflection of f about the x-axis. All right, so if it is a reflection, guys, what you need is to know that a reflection in the x-axis, you multiply f of x by a negative. So that means h here is equivalent to negative f of x. That's a reflection in the x-axis. So it means hx is equivalent to negative times f of x, remembering that your f of x was equivalent to -3 tan x. So you're going to multiply to -3 tan x, which is 3 tan x. So that was the equation of the reflection. So if you reflect about the x-axis, if it is about the x-axis, you multiply by the negative to the function that you are given, which is that way. Okay, so I think everything is clear. Let's check the other part of the question on 5.2. So 5.2 is nothing to do with 5.1, so you can even remove everything there. So you're given on 5.2 that sketched below is the graph of gx, which is equivalent to a cos of bx. On 5.21, write down the values of a and the value of b. So a here represents the amplitude, which is the maximum value, where our graph is actually having the maximum value. So according to the first value that we have here, the graph that we have, it was supposed to start at 2 here. From the graph, of course, it was supposed to be at -2, remembering the graph, of course, guys. But now we are seeing this graph starting at -2. We are now having our graph at -2. So that is the maximum, the peak value that we are now having from 2 is now at -2. So A here is going to be equal to -2. All right, B is taken from the period part. Remembering this is cos. From this graph, our period is 360. From the previous one, we've got 360 over 360, which is going to give us a 1. So B is just going to be a 1, which is direct. So which means we can have this graph as gx is equivalent to A, which is -2 cos of theta. So this can be a new function in this manner. All right, so I think this part is a little bit direct, but if you do not understand, let me know on the comment section so that we can work with this together. Use the graph to determine the values of x for which gx is greater than 0. So gx is greater than 0 when it is a positive. That is, this is our gx. Our gx is positive above the x-axis. So it's supposed to be a positive above the x-axis. So as you can see from this, it is negative. When it reaches 90, it is now at 0. Then it starts to be positive. It's above the x-axis. As 270, it goes down, which is now in the negative. So it is starting from 90 up to 270. So this we can even write as our x greater than 90 degrees, but less than 270 degrees. Not equal to, this is f of x is greater than gx. I mean, if it was given as gx is greater than or equal to 0, your answer was going to be having equal to and also equal to here. But because we are not given that, it is just going to be 90 degrees up to 270 like that in this manner. All right, so take note about how you write your answers, guys. On 5.23, determine the range of H if H is the image of G, if G is shifted down 2 units. All right, take note. Our G here is shifted down 2 units. Previously, our GX is given as, okay, let me write, this is 5.23. You can even utilize this space. All right, so 5.23, previously, our GX is given as -2 cos X. So this is actually -2 cos of theta, so not X. So when it is shifted down, two units down, it means you are affecting the values of Y. These are the values of Y. And when affecting the values of Y, you affect according as it is. If it is down, you are subtracting. If it is up, you add. So this one, it is 2 units down. So that means our HX, which is the new equation, is -2 cos theta minus 2. So we have shifted it down with -2 units. But this is not important actually about the format that you're going to have. What matters is that all the points, they are going to be shifted 2 units down. So the minimum value here is going to be shifted 2 units down. So we are at -2. We subtract 2 units down, which means we are now at -4. So this point is going to start at -4. We move on to the maximum value, which was corresponding here with 2. We move it 2 units down. So which means this point is going to start at 2 minus 2, which is it is going to start at 0. So that means the range definitely is going to shift, because range we are referring to the values of Y. So Y is now starting at -4 and ending at 0. So that is the new range that you're going to have. So in this case, the range is going to be affected from -4 up to a 0. So which means Y is going to be greater than or equal to -4, but the same Y is going to be less than or equal to 0. All right, so that is the values of Y that you're going to have, or someone can write this as -4 up to 0 in this manner. Still wanted the same thing. All right, another part on 5.24, determine using the graph the value of -2 cos 0 degrees, 1 degrees, 2 degrees, up to 360 degrees. Okay, so this typical question here, it simply shows you from 0 to 360, from 0 here to 360. That's a complete cycle. We have completed the cycle of the given function, and so we are simply referring to one cycle of the given graph. So this is going to be -2 times the full cycle of 1, which is a -2. So that's simply representing a complete cycle. So it's going to be a -2. All right. On question 6, I think we're done that one. Okay, that was actually 12 marks in total. So on question 6, we are now given the information which relates to our solid shapes. So we're actually given a solid shape in this case, where we are given the diagram that we have is simply showing a cup with a volume of 117 pi cubic units. So this is the volume of the cup. So remember that a cup is actually a cylinder. So this is a cylinder, guys. Okay, so we are given the inner diameter is 60 millimeters, and ignore the thickness. Okay, so we've got 60 millimeters, but take note the volume here is given in cubic centimeters. So that means there's a need for us to change the units. So we can change the units here. That is our diameter being 60 millimeters, we are supposed to convert to centimeters. So what's the relationship between centimeters and meters? 1 centimeter is equivalent to 10 millimeters. So for you to convert the 60 millimeters, you simply have to divide by 10. So that means our diameter is 6 centimeters. But knowing that if you are dealing with a cylinder, the most important part is to know the radius. So the radius in this case, we know that radius is simply the diameter over 2. So it's 6 over 2, which is 3 centimeters. So we are given a radius of 3 centimeters. Okay, Let's see what do we have and what are we asked. Yes. So on question 6.1, we are given to calculate the height of the cup. So take note, the height of the cup we are not given here. That is our h. That is the height of the cup. But we are given the volume before. There is a volume here, which is 117 pi cubic centimeters. We can play around with the volume because we know the formula for volume of, remember we said this is a cylinder. So the volume of a cylinder is given by the base area times height, which is pi r squared, which is the base area referring to a circle times the height of h. All right, so the volume is there. So all you need is to find h. So you can substitute the values. Volume, that's 117 pi. So we are going to have 117 pi is equivalent to pi r squared, which is pi times the radius squared. So r here being our radius, which we got as 3 centimeters. That was the radius, 3 centimeters. So it's going to be 3 squared times the height. So you need to find h. So it's 117. 117 pi is equivalent 3 squared. That's 3 times 3. You can use your calculator. That is 9 pi h. So since we need the value of h, we can divide by 9 pi both sides. Divide by 9 pi both sides. So this can cancel. So you can find the height of the given cylinder. So this is 107. As you can see, guys, pi and pi are actually canceling here. So you can just divide 117 divided by 9. So it's 117 divided by 9, which is 13. So we are actually obtaining 13 centimeters as the height of the given cylinder here. So this is 113 centimeters, not 118, but 13 centimeters. Where am I obtaining 118? Okay, so if for 13 centimeters as the height, then on 6.2, they are now given that calculate the total surface area of the water that touches the cup if the cup is 80% full with water. All right, so if the cup is 80% full of water, it actually affects the height of the water where we are having the water. When it is full, then the height is 13. But now it is 80%, which means somewhere here, that's where we have got our 80%. So which means it is going to affect the height. So you are supposed to find the 80% of the height. So knowing that the total surface area is given by this formula, so this is 6.2, the total surface area of a cylinder is, we've got the base area, the total base area, which is the pi r squared plus 2 pi r h. All right. So here, I want you to take note of what is happening. We are dealing with water. So the cylinder is supposed to be like this. The total surface area of a cylinder, we are given 2 circles here. So it's supposed to be 2 pi r squared plus 2 pi rh. All right. So what we are actually dealing with is the total surface area of the water, the one that we have. So we are going to have the base here of the circle and another one on top. And the radius, remember, is 3. So that means we are going to have, okay, just write our formula here, 2 pi r squared plus 2 pi rh. But here we are going to multiply by 80%. Take note, the height is, it is now 80% full. So you multiply by 80%, of which 80% is 80 over 100, which is 0.8. So it's simply multiplying by 0.8. All right, so that will be the total surface area, which is 2 pi times r squared. Remember that your radius here was 3. So it's going to be 3 squared. So it's going to be 3 squared plus 2 pi r, which is the radius again, which is 3, times the height times 0.8. So the height here is 13 centimeters, but we are going to multiply that 13 times 80%, which is 0.8. So it's going to be times 0.8. So take note, when you are given that percentage, it affects the height. It is full of water, so it affects the height. So in this case, yeah, we can just use our calculator at once to determine everything. So we can have 2 pi times 3 squared, all right, in a bracket, plus in another one, we have got 2 pi times 3 times 13 times 0.8 or 80 over 100, still one and the same thing. So we are going to obtain 252.58. Okay, so that's 252.58 square centimeters. Take note, you are dealing with the surface area, so it is measured in square centimeters. Okay, so that's what we had, guys. If you have any other way or any other method of determining this, then let me know on the comment section so that we can play around the question once again. We can work on it so that we can actually see what was happening here. All right. On question 7, we are given that question 7 and 8 give reasons, or from these ones, give reasons for all geometric or for all geometry statements in question 7 and 8. The first one on question 7.1, we are given complete the statement so that it is true. The line drawn from the midpoint of a triangle parallel to the second. Okay, if we draw a line from a triangle like this, so we are drawing a line from the midpoint of one side parallel to the second, like that. So what does it do? It bisects the other side. Okay, so that is the third side. So that one, guys, that is from your midpoint theorem. So here it bisects, okay, the other side, which is actually to be the third side, bisects the third side. So this statement is now true. On 7.2, we are given that ACS is a triangle, P is a point on AS, and R is a point on AC, such that PSQR is a parallelogram. Okay, so you're given P S from P to S to R to Q, it's a parallelogram. Remember, a parallelogram, guys, that the opposite sides, they are parallel and equal. So also these two sides, they'll be parallel and equal. All right, so that's what you're going to have, because the parallelogram, that one. And we are given that PQ intersects AC at B, so that B is the midpoint of AR. So here, B is a midpoint of AR, okay, of AR here from A to R. So that means from A to B, it is the same as from B to R. These two, they are equal. All right, because B is the midpoint. Okay, we are given B as the midpoint there. Then QC is joined also. CR is equal to PC. From C to R here, this one, all right, is equal to PS. Okay, that's PS here. C1 is 50 degrees. Okay, that's angle C1. We put C1 and C2. So C1 here, it's 50 degrees at this point. All right. BP 60 millimeters from B to P here. That's 60 millimeters. All right, so this is the information that we are given. From this information, the first part is on 7.21 was to calculate the size of angle A. All right, size of angle A, this is our angle A here. That's our angle A. All right, let's see. If we are to check, guys, the only angle that we are given here is angle C1. So which means we are supposed to play around from that C1 of 50 degrees until we reach to angle A. There's something that is familiar between angle A and angle R3, this angle R3 here. These are actually alternate angles. As you can see, we are creating a Z. So remember that alternate angles are equal. All right, so let's do this here, 7.21. Let's try to work it here. So like I said, the angle A that we need is equivalent to angle R3, okay, which is from alternate angles. Okay, so how can we find R3? Let's see what we have so far. We are given that this side, CR, this one, CR, and PS, they are equal, these two lines, okay? And also, okay, let's write down, because these reasons, they are very, very important. We have from R to C, which is equal to PS. These are equal, this was actually given. Then PS here and the QR, we say these two, they are equal. Remember, we say these two are equal from the parallelogram concept, opposite sides, they are equal. So PS is actually equivalent to QR, okay, from our parallelogram concept. So if these two, they are equal, but remember we said PS and RC or CR, they are equal, these two. The same PS is equal to QR. So it simply means RC or CR and QR, they are equal. So definitely CR is going to be equal to RQ. So this means if C and R, if CR here and the QR or RC, these two, if they are equal, let's present maybe in black like this. If these two, they are equal, then triangle CQR or triangle CRQ is now an isosceles triangle, where we know that in an isosceles triangle, base angles are equal. So angle Q1 and angle C1, they will be equal. The Q1 is going to be equal to C1. That is from the base angles of an isosceles triangle. So this will be 50 degrees. So that means if this is 50 and this is 50, we can calculate angle R3 direct here, because we need angle R3, which is equal to angle A. So angle R3 can be taken from the 50 and the 50 here if we add these two. Why? Because R3 is the exterior angle of a triangle. Remember that the exterior angle of a triangle is equivalent to the sum of the opposite interior, that is 50 plus 50. Or you can calculate this R inside this triangle here by subtracting these two angles from a triangle. Remember that angles in a triangle add up to 180. So it will be 50 degrees plus 50 degrees, of which 50 plus 50, that is 100 degrees. So it's going to be 180 minus 100, which is 80 degrees. So this angle inside at R here is 80 degrees. So to find R3, we are going to subtract now from 180, because we know that angles on a straight line add up to 180. So it's going to be 180 minus 80, which is 100 degrees. So as you can see, angle R3 is the same as the one that you're going to obtain from adding 50 plus 50, which is 100 degrees. So if R3 at this point here is equivalent to 100 degrees, it means A is also equivalent to 100 degrees from the alternate angles concept. So therefore, angle A is also going to be 100 degrees. So I think I was explaining the method, I mean, the important points that you're supposed to write down. So you can even write them down, guys. All right. On 7.22, we are now given to determine the length of QP, and that is 3 marks. Q to P, where do we have QP? This is Q P here. All right, we need the length of QP. All right. What actually do we have from Q to P? Let's see what we have from the previous concept. Okay, this is 7.22. Let's first write it down here. From the previous part that we had, we understand that from Q to P and from R to S, these two, they are equal from the parallelogram concept. Remember, we talked about parallelogram. So QP and RS, they are actually equal. All right. So we are saying that QP, RS, they are equal. Okay. Is equal to RS. From the parallelogram side, parallelogram, remember the opposite sides of a parallelogram. Okay. So from the opposite sides of a parallelogram, these two, they are equal. But can we find RS? Because there is a 60 that we have here, 60 millimeters, and it has something to do with the RS. What concept is that? Remember, we are told that B is the midpoint. Remember, we have got B as the midpoint. So if B is the midpoint, that line is drawn and we've got parallel lines here. So it means also P is the midpoint. Remember the midpoint concept, these two lines, they will be parallel. So P is also the midpoint, all right? So if P is the midpoint and B is also the midpoint, it actually means that this BP is half of RS, or RS is twice BP. All right. So as you can see, these two, they are equal from A to B. B to R is the same thing from A to P. It will be equal from P to S, okay? So AP and those ones you can even write or not write. AP will be equal to PS from the midpoint concept. But what matters is this part of BP and RS, okay? That BP is half of RS. So BP is equivalent to half of RS. That is from the midpoint theorem. All right. So if this is half of RS, that means we can find RS because BP is already given as 60 millimeters. So that means BP 60 millimeters is equal to half of RS. So to find RS, simply multiply by 2 both sides. So that means RS is going to be 60 times 2, which is 120 millimeters. So that is the length of RS here, 120 millimeters. But remember what we said about the parallelogram. We said RS and the QP, they are equal. So therefore, we have QP. So therefore, our QP is going to be also 120 millimeters. So guys, your methods, they might differ, but having the same answer. What is important is to make sure that we are obtaining the same answer no matter the way that you're going to use. All right, so that was question 7, having a total of 9 marks. We are going to cross-check the question number 8, where we are given that A, B, C, D is a parallelogram, where E is a point and F are the points on A, B respectively. We've got the point E and F here. Okay, we can see them from the diagram. Such that AE is equal to CF. So from A to E here, it is the same thing as from C to F, which is this point. All right. Then DE is produced to J and CJ is drawn. Okay, so it's produced to J and CJ is drawn. BF from B to F here is produced to K and AK is drawn. All right, so that's it. Okay, so the first part of the question, which is prove that on 8.11, DJ is parallel to BK. Okay, we need to prove that from D to J, it is parallel to BK. Okay, this is what we have. Where do we have our DJ? All right, this is what we have here. From D to J here. All right, this is our J here. And B to K. So we want to prove that these two lines, they are parallel. Okay, I want to prove that. First things first, let's check what we have about the parallelogram, because we're given a parallelogram, guys, that ABCD is a parallelogram, ABCD. So take note, these sides, AB is parallel to DC, and they are also equal. Also here, BC is parallel to this side AD that we have here, and they're also equal. All right, so these two, they're equal like that. So what can we do, guys, to prove that these two, they are equal? Okay, AB is actually equivalent to DC, and these two, they are equal from the parallelogram concept. I think if I can write it here, I can actually work something nice. Okay, this is 8.11. I'm just going to utilize this space. I want to be near the diagram. Okay, so this is DJ is parallel to BK. So it's not like this method, you know them direct, guys. It's a play around with the diagram until you get to the answer. All right. So AB and DC, we say these two, they are equal, AB and BC. All right. Then if we are to check what is happening, this is actually a straight line from A to E. All right. Then from E to B, which is the whole of this line, is the same thing as from D to F, and also from F to C, which is actually a parallelogram. So it's part of a parallelogram. Okay. But there is something happening between A and E. We are given that these two, they are equal, AE and FE. Okay, let me write it stage by stage. Okay, I'm saying from A to E, the one that we are given, plus E to B, we want to combine this, the part that we are given, E to B. All right, these two, they are equal. If we check, we have got the same thing here from D to F, because we need this FC. So we're going to take from direct D to F and F to C. So it's the same thing as D to F plus F to C. But remembering that these two, they are equal, AE, this AE here, and the FC, they are equal because that one we are already given. AE is equal to FC. We are given here, and also on the diagram, we can see it. So if these two, they are equal, AE and FC, but once we said if we add these two, they are equal, it means the remaining two sides, they are equal. So definitely EB is equal to DF. Guys, are we together here? It's just like writing 2 plus X is equivalent to Y plus 2. If these two, they are equal, the 2 and the 2, that means X and Y, they are also equal. All right. So this is actually a consideration that we have from this. Therefore, these two, they will be equal. So if EB from E here, from E to B, if these two, they are equal, and D to F, if these two, they are equal, definitely that means we are going to have DF here, all right? DF and ED, they are going to be parallel because this is a parallelogram that we have. And these two sides, they are equal from E to B. These two sides, they are equal, so they are parallel, all right? So that definitely means that EB is going to be parallel to DF. So what is the concept? That's a because this is part of a parallelogram. Remember, BF is a parallelogram. So these two sides, they are already parallel. So these two sides, they are going to be also parallel. So it's also opposite sides of what? Of a parallelogram. They will be parallel to each other. All right. So if we are to check now, because we say these two, they are equal and they are also parallel from E to B. So that means from E to B to F here and also to D is now a parallelogram. Why are we saying this? All right, let me write first. Here we are now having a parallelogram from this point E to B to F and to D because these two sides, they are parallel and also equal. These two sides, they are parallel and equal. So if it is a parallelogram that we have, already we are given that these two sides, they are parallel, BF and DE. These two sides, they are already given here. BF there, BF is already parallel to DE. All right. BF being parallel to DE, these two sides, it simply means the same thing that we have from B to K. It simply means from B to K is parallel from D to J there. From D to J, the whole of that line is actually the same because it's in the same line. So BK is in the same line with the BF. This DJ that we see is in the same line with the DE. So they are parallel to each other. So this is what we actually needed to prove, that DJ is parallel to BK. So we can even conclude that therefore DJ is parallel to BK. All right, so a lot, guys, that we had was actually a lot. So for you to prove it, actually you work with different ways, different formalities. I don't know which one is best for you. All right, on the other part, we are now given on 8.12, we need to prove that angle E1 is equal to F1. Okay, this is what we have. Where do we have angle E1? E1, E1, E1. This is E1 here. This angle E1 that I'm indicating here is equal to this angle F1. So if you are given that type of equation, it's for you to trace out equal angles until you find another one. So it depends with where you want to start. Okay, let me just utilize this space because I want to get back near the diagram. Okay, so this is 8.12. So we want to prove that angle E1 is equal to angle F1. So what do we have on angle E1 that makes it equal to F1? Let's focus with E1. So it depends. You can start with F1. Okay, as for me, I'm going to work with E1. Let's find any other angles that are equal to E1. Okay, E1 here is also equal to E3 from the vertically opposite angles. The same E1 that we have here, if we are to take note from the parallel lines that we have, it is going to give us the angle that we have at D1 here. Okay, we are having this first. B2, okay? Also, E1 is the same as the angle D1 here from the corresponding angles because these two lines, they are parallel. All right. So here it is going to be difficult to work from B2. Do we have anything that has to do with B2? All right. We can even take it at B2 or you can even take it at D1. So E1 is equivalent to D1. So about D1, these are actually corresponding angles. Okay. We can even use this way. Angle E1 is equal to angle B2. Okay. Is equal to angle B2. For angle B2, we are now referring to alternate angles. So these are actually alternate angles. Okay. Working with E1 equal to D1 here, we are now at D1. This D1 that we see and F1, they have something in common. You can see there is a Z that is being created. So these are alternate angles. So angle D1 is equivalent to F1. These are actually alternate. We've got alternate angles there. So if these two angles are equal, D1 and F1, but previously we said E1 is equal to D1. So therefore, definitely it means angle E1 is equal to F1. All right. Let's say you took it this way to say E1 is equal to B2. What do we have? B2 here and this F3, they are equal. You can see we are creating a Z here from the alternate. So these are alternate angles. So B2 is equivalent to angle F3. That is alternate angles. Yeah, that's a Z, that one. So we can take it from alternate angles. All right. But angle F3, if we are to cross-check what is happening with F3, angle F3 is equal to F1. All right. Angle F3 is equal to F1. What makes these two to be equal? These are vertically opposite angles. We are actually referring to vertically opposite angles. So if F3 is equal to F1, but we once said F3 is equal to B2, so that means B2 is equal to F1. So therefore, B2, which is E1. So therefore, E1 is equivalent to F1. So these two actually they're equal. So there are so many ways, so many ways, guys, that you can use. So many. So let me know, guys, if you find any other way that you used to prove that these two angles they're equal. Yes, it can help someone on the next video or on the next platform. So please let me know, guys, so that we can work with that methods. But there are so many methods that we can use there. All right, on question 8, we do not need all the rest. So let's just remove this. On question 8.2, we are now given in the diagram, O is the center of a circle. All right, so there is O here, which is the center of a circle. And we are given A and B lies on the circumference of a circle such that AP is equal to BP. So from A to P and B to P, they're equal. Actually, that part you're supposed to know it if you are given two tangents from the external point of a circle at their point of contact, they are equal. So the question now on is to prove that AT is equal to BT, that is 8.21. So on 8.21, we can even put it here so that we can prove it fine. So we want to prove that AT is equal to BT. All right, what can we do, guys, to prove that AT is equal to BT? All right. This is our AT. From A to T, they are saying it is equal. From B to T, these two, they are equal. Okay. First thing, we are given that AP and PB, those two, they are equal. Okay, let's see. This is gonna help. All right. So that's what we are already given. AP and BP, these two, they are actually given. All right. Then we have got from O to A and from O to B, these two, they are equal. So it actually makes this to be a kite, guys. If you can check, if these two sides are equal and these two sides are equal, it's now a kite. All right. So let's write that statement. So OA is also equivalent to OB. This is the radii concept, the radius. Okay, so radii equal. So if they are equal and we are now having a kite, so it means the whole of this shape OAPB. Okay, let's write OAP to B is a kite. All right, if it is a kite, remember the concept of a kite. It means, it says that the bisectors, the diagonals here, they actually bisect each other. We have got a diagonal OP and a diagonal AT. They bisect each other, and they do not just bisect each other, they bisect each other at 90 degrees. So if they bisect each other, it means AT is equal to TB. All right, so which is BT. So it means, therefore, AT is equal to BT. We are now taking from the properties now of a kite that the bisectors bisect each other. So here bisector, oh, not bisectors. I wonder why am I still repeating this? These are diagonals. So diagonals of a kite bisect each other. Okay, not each other. Not, am I still saying this? Okay, the diagonal of a kite. Okay, this diagonal OP is going to bisect not everything. It's not a rectangle, this one. Okay, it's not. So this is actually OP, which is that diagonal bisects. So OP bisects diagonal AB. All right, so diagonal AB is going to be bisected by OP, not OP. OP is not going to be, so guys, sorry for that. I just hope someone was seeing this and what they were saying, what is trying to say here. Okay, so that's what we had. Now on 8.22, OTA is equal to, we want to prove that OTA is 90 degrees and it's just 1 mark. Okay, OTA, this is OTA. So remember what I said here, that this diagonal is going to bisect another one and it bisects at 90 degrees. So definitely OTA is going to be equal to 90 degrees. So this, what is the reason now? What can we say? You can just say these are properties of a kite, right? You can just, yeah, you can just write it this way, properties of a kite, because we already know this from that concept of a kite from the diagonals. We already stated that. So that was actually the paper. That was actually the paper, guys. Total of 100 marks. Yeah, that was a total of 100 marks. So are you going to totalize this? Are you going to take the whole of 100 marks? Yes, it's very, very possible. It's very, very possible for you to do that. What can you do? What is required is for you to work as much question papers as possible, revise with textbooks, question papers, and also watching the videos that we have at Maison African Motives. It can help you to upgrade your grades. And don't forget, guys, as a family, to share our videos to your friends and colleagues, and to share our social media platforms to your friends also on Facebook and also on YouTube platforms. So don't forget to share. As we are sharing, we are improving, or we are actually growing our family so that we reach more numbers as a family. So that's it, guys, from Maison African Motives. Let's catch up in another video. I think, yeah, let's see in another video, guys, till we meet again.